Greetings, scholars. Beautiful Mind here. We have the following question that comes from College Algebra 2 from section 3.2. It's question number 19 in the homework for section 3.2, and out of the textbook is it comes from section 3.2, question 89. Let's see. Maybe if I go like this. So it says, and here, let's go like this too. For the following function, briefly describe how the graph can be obtained from the graph of a basic logarithmic function. Then graph the function and state the domain and the vertical asymptote, right? So here we have f of x equals 6 minus the natural log of x. So the general shape of a log, remember, it's the inverse of the exponential, which means if we take an exponential function and rotate about the diagonal y equals x, we get the graph of log. So natural log, the parent function here, or the base function here, is going to be natural log, right? And the general shape for a regular log function without any manipulations, there's going to be a vertical asymptote on the y-axis, right? Where the y-axis serves as the vertical asymptote. It also passes through the point 1, 0. And like below the x-axis is coming up along the right side of the vertical asymptote. It passes through the point 1, 0, and then it kind of veers off to the right, right? So that's the general shape of a log function. Could pull it up, but I think we'll see it in just a moment. And then the added component here is we're pulling from College Algebra 1, where we were doing transformations of functions. So looking at this function, I see two transformations at play, right? Again, the base function is natural log of x, and then on the outside of natural log, we multiply. The first manipulation is we multiplied the outside by a negative, right? So from College Algebra 1 with transformations of functions, when we manipulate the outside of a function, it generally causes a vertical change and it follows our intuition, right? So we actually have two manipulations on the outside of ln. First, we multiplied the outside of ln by a negative. So and outside manipulations generally affect the y. So it's like in this case, when we multiply the outside by a negative, it's like our y values are going from positive y to negative y, right? So, if what I'm saying is a little bit foreign, it wouldn't hurt to just go back and dig and like do a recap on transformations of functions of College Algebra 1. I can say that there's a total of 10 transformations at play. I think it's like 6 of them that are rigid, right? And which means it doesn't distort the shape, it just moves it side to side, or flips it, either up or down or horizontally. And then there are 4, I think that's how many, of, I think, whatever the opposite, for whatever reason, I can't think of the opposite word for rigid. But there are 4 transformations that distort the shape, right? But there should be a total of 10 transformations. 2 that move it up and down, 2 that move it side to side, 2 that flip it either vertically or horizontally, and then 4 that stretch it either vertically or horizontally, right? So again, multiplying the outside of our base function by a negative makes it's like our y's go from positive to negative, so it flips it vertically over the x-axis. Then we added a positive 6 on the outside. So that's like adding 6 to all the y values. So that takes so we have the general shape for a log. We flipped it top to bottom, then we go up 6, right? So those are the 2 transformations at play here, right? And again, that comes from College Algebra 1. Okay, so I'm just trying to get the image back here. So then it says describe here. I guess we can zoom in on this. So then this says describe how the graph of f of x can be obtained from the graph of the basic log. So the graph of this f of x is a transformation of the graph of natural log by reflecting it. We said we flipped it vertically over the x-axis. And then a translation 6 units, or we said what, up, because we added a positive, we went up by 6 units. Oh, let's go like this. Okay. So then now I'm just trying to do a showcase on, well, not just on graphing, but this question popped up. So now to graph this, let me see. Our log 2, so we only have 2 options here as far as our graphs for this one. The upper right is the log function. The bottom left is the exponential, right? But we want log. So the general shape of log is that upper right there. Okay, let me see if I can get this back. Okay, so when I click on that log function, now we're doing the graph of natural log, right? I think from the text we said that natural log is nothing but common log base e, right? So that's why you see that base e there. And then, so all I did, let me do that one more time. Let me clear this. Okay. All I did is I clicked on the upper right hand corner for this one, right? I just clicked on the upper right hand corner for my log function. Are you gonna work? And then I just clicked randomly. I just clicked somewhere randomly on the graph. And then this menu pops up, right? So all we did, we started with the basic log function, and then we applied the two transformations. I think we reflected over the y-axis, so I'm just gonna click there. Sorry, not the y-axis. It was vertically over the x-axis. And then we moved it up by 6. So this vertical shift, I'm going to drag it until I see 6 right there. And then that's it. Let me see. I think we have to identify the vertical asymptote as well. So I'm going to close this out. This is our image. Then, let me see. Maybe not. Because I don't see the line tool, so that should suffice. Yeah, let me hit save. Right. We get an image like this. I'm gonna go ahead and check it. Okay, so hopefully that helps with the graphing. At least that was a demo on this example. And then in general, the domain of a log, log is defined. The log function lies entirely on the right hand side of the y-axis, right? So the very left to the very right, the very left is like it gets really close to x equals 0, and then it goes off to infinity to the right, all right? So then the domain is going to go from 0 to infinity. And we don't actually reach 0. We get infinitesimally close to it, but we don't actually reach it. So 0 to infinity. Okay. And then the vertical asymptote, in this case, notice we did not move it side to side. We only moved it up and down. So then the y-axis remains as our vertical asymptote. So that's going to be x equals 0. Okay. So hopefully, hopefully that helped to clear up, just this question, at least in particular. I know some students were like a little nervous about graphing, but you just saw, and like, just ask, right? And I'll try to walk you through it as best I can. But you saw, again, all I did was I clicked on the log function. It gave me the generic log, and then I applied the transformations and I hit done, right? It does take some effort. It does take some practice. So give it a go. And with that, we're going to end the session here. And from one beautiful mind to another, have a great day. Take care. Peace. It's like the middle of the night. You can see my time up there. So I got my sexy, let's go. Sexy cat, it's not your fault. What are they feeding you? All right. Who was that? Carl Weathers, RIP. Yeah, that was really sad. Anywho, take care. Peace.